All right, so now we've gone through most of 3.5. We did some work problems, we did some mixture problems. Now we're going to do the distance problems. So the formula that you need to remember to do the distance problems is the distance is equal to the amount of, the speed or velocity that you're going times the amount of time that you're driving or walking or doing whatever at that speed. So number 9 starts off by saying that a passenger train made a trip to the fueling station and back. So if it went to a station and back, like it goes the same distance, so like the train goes from point A to point B, and then it goes from point B back to point A. They're gonna have the exact same distance, D, right? So that means that, if they have different R's, like rate 1 and rate 2, or velocities, then that means they're also going to have different times. So time 1 and then also time 2. But, they're going to have the same distance if, so regardless of what happens, because they went from one place and then back. So same distances. On the trip there, let's say that this is the trip there and this is the trip back. These problems are kind of challenging just because they're like more physics than just a formula. You have to kind of understand like how direction works and things like that. But maybe focus more on the mixture and the work problems. But the distance problems are pretty tough, but they are pretty neat too, in my opinion, because it relates more closely to physics. On the trip there, it traveled 76 miles per hour. Miles per hour is a dead giveaway that that's your rate. So for this first distance that we have here, distance is equal to the rate, 76, times the time. We don't know what the time is yet. And then on the return trip, it went 40 miles per hour. So that's a different rate, just like what we anticipated. So 40 times the amount of time. So these are going to be different times. It said, how long did the trip there take if the return trip only took 19 hours total? So let's see here. So how long did the trip there take if the return trip took 19? So 19 is the return trip, so the trip going back. So we just need to solve for x, which is the amount of time that it took to get there in the first place. So we do 40 times 19, to get this total distance. So the distance is equal to 40 times 19. Let's see what that is. Is that 760 or something? 40 times 19. Yeah, 760, so 760. So remember what we said, though. The distance there is the same as the distance back. So if the distance back is 760, that's the same distance as, the distance there. So 760 is equal to 76 times x. Now we just need to solve for x. So we divide both sides by 76 and we get x is equal to 10. So 10 hours is how long it took for the trip there, going 76 miles per hour. All right, and that's it for number 9. Let's move on to number 11. So a jet flew to Moscow and back. So again, same kind of startup, goes from point A to point B. And that's the same distance as from going to point B to point A. So these distances are the same, but their rates are probably different. So that means that their times are different as well. All right, so let's see what they give us. It took 1 hour less time to get there, than it did to get back. All right, so that's a little bit of a change from the previous problem. The average speed on the trip there, so here's the there, here's the back, going back. So let's see here. The average speed on the trip there is 420 miles per hour, so that means that the distance is equal to 420 times t. And then the average speed on the way back was 280, so d is equal to 280 times a different t. Now, here's where the interesting thing comes in handy. It says it took 1 hour less time to get there. So to get there, it was 1 hour less than it did to get back. So that means that if we want to find, the amount of time that it took to get back, it's going to be the amount of time that it took to get there, but there is 1 less than that. So that means that we're going to add on 1 to it. And then we can solve it. So check it out. This doesn't really solve for a distance like the previous problem did, but since these two distances are the same, I can set these two equations equal to one another. So that's what I'm going to do. 420 times t is equal to 280 times t plus 1. If I distribute in the 280, I get 420t is equal to 280t plus 280. Then if I subtract 280t from both sides, I get 140t is equal to 280. Then if I divide both sides by 140, then I get t is equal to 2. So that means that it just took, how many hours did it take? Just 2 hours. Now that's it for the distance problems. If you need some more help on those, consult your math or I guess your science, your physics teacher. They can help out as well. I'm going to move on to the next worksheet, which is the graphing worksheet. If you have a graphing calculator, it's going to help out a lot. In fact, that's what I'm going to be using on the majority of these. I might do like one or two without a graphing calculator. So make sure that you have one of those for these problems. And that's it for this one. Thanks.